In 1928, the world's first spring-loaded air-swept mill, built by our predecessor company, Kurt von Gruber Maschinenbauanstalt of Teltow near Berlin, is launched onto the market. It's called a Loesche mill and comes with 2 grinding rollers and its own patent. It already has all the essential features of today's modern air-swept vertical mills. Even the very first Loesche mill features an integrated dynamic classifier. Several such mills are used in Europe's first large-scale coal dust-fired power station, Klingenberg in Berlin, where they grind coal at a raw coal rate of around 12 metric tons per hour. In 1948, the company in Teltow, East Germany, is nationalized. In the same year, the Loesche Company is founded in Düsseldorf. The Loesche range of products for comminuting solid fuels includes roller grinding mills with 2, 3, 4, and 6 rollers. Loesche coal mills are mainly used in the cement industry for coal firing of cement rotary kilns, in the iron and steel industry for direct firing of coal dust into blast furnaces, for coal-fired boilers used in the generation of electricity, steam, and heat, and in coal conversion plants, gasification and liquefaction of coal. A Loesche mill consists of various assembly groups and individual parts that are erected on-site according to specific assembly instructions. The foundation frame, 3 or 4 pedestals with rocker arms, and the hydro-pneumatic spring assemblies are already assembled. This assembly is now completed with the addition of the 4th pedestal. The hot gas duct and the grinding table with the air guide ring and the louver ring are then installed, and the grinding plate and hydraulic piping are positioned. At the same time, the drive group is pushed underneath the grinding table. Next, the working platform and the mill housing are attached. This is followed by the assembly of the classifier housing and the positioning of the classifier cage and the grit return cone. The grinding rollers are inserted into the rocker arms at the same time, and the wear parts are then installed. The drive and the service platform complete the classifier. Once the grinding rollers have been swung in, the housing cover is assembled. The grinding material is comminuted in the Loesche roller grinding mill between the rotating horizontal grinding track and the fixed grinding rollers. Grinding is effected primarily by the force of pressure with a small amount of shear force. This effect is created by tapered rollers, whose axes are angled at 15 degrees with respect to the horizontal grinding track. Comparative investigations conducted during the 1930s showed that this is the best way of achieving optimum comminution with minimum wear. A Loesche coal grinding plant is put into operation by carrying out certain individual steps. Classifier commissioning. Heated process gas flows through the mill and warms the entire plant in order to prevent condensation from forming. The rollers are raised up whilst the plant is being heated and before the grinding table is started up. The coal feed is switched on, and the raw coal is delivered to the grinding table via the feeding chute. When the material feed is switched on, the grinding rollers are lowered and the comminution process starts. The grinding rollers roll over the coal, which is comminuted by the force of the hydro-pneumatic roller spring system. The rotation of the grinding table throws the coal outwards to the area of the louver ring, which surrounds the table, where it is dried by hot gases. The coal is then transported to the classifier. When the coal particles come into contact with the hot gas, the water evaporates spontaneously. Based on the particular setting, the classifier rejects coal that has been comminuted into pieces which are still too large. The coal then falls back to the grinding table, where it is comminuted again. The product is conveyed past the classifier and exits the Loesche roller grinding mill in the gas flow. The following preconditions must be met before an inert coal grinding plant can be started up. Fill level of hoppers 2, 3, and 4 is above the minimum fill level. The inspection openings on the filter are closed. Paths for conveying dust have been activated. All auxiliary drives are switched on. Oil lubrication for gearbox, mill hydraulic system. And all system flaps must be set to closed, as shown at position 7, for example. The flat valves upstream of the mill and downstream of the filter, position 7, are opened. The process gas fan, position 9, is started up and operated with a minimum volume flow. The plant is inertized by feeding in nitrogen or carbon dioxide from the corresponding dispensing vessel, position 15. Inert gas is applied to the following units. Position 6, filter. Position 1, mill. Position 14, hot gas generator, and position 16, dust hopper. The gas analysis equipment is activated in order to determine the carbon monoxide and oxygen content of the process gas. The measuring points are found at position 1, upstream of the mill, downstream of the filter, position 6 in the filter, and position 16 in the dust hopper. The seal air fan, position 1A, is switched on. The sealing air at the grinding table seal, the grinding rollers, and the classifier drive is needed in order to prevent dust from accumulating in the bearings. The flap in the return gas duct, position 11A, and the stack flap, position 10A, for controlling the volume flow of exhaust gas are moved to their start position. The volume flow of process gas is measured via a Venturi tube, position 8. This volume flow is regulated by means of the vane control, position 9. The volume flows of process gas within the system are regulated via suction pressure control. The controlled system consists of measuring the suction pressure before the mill and the regulating flap valve for the exhaust gas flow in the stack, position 10A. The set point on the pressure regulator, PIC, before the mill is usually set to a value of around -3 millibar. All the preconditions for starting up the mill have now been met. The hydraulic system is switched on, and the gearbox with grinding table, as well as the classifier drive, are started up. The coal grinding plant runs as a self-inert system. The maximum oxygen content of damp process gas is set to 12% in accordance with safety regulations. These plants are usually operated at an oxygen content of between 8 and 10% with moist gas. The oxygen content of the process gas is precisely adjusted via the controlled feeding in of fresh air, position 13. The higher the oxygen content of the process gas, the lower the dew point temperature. The oxygen control QIC is activated. For process engineering reasons, low dew points are desirable in the process gas. This ensures there is a safe clearance between the operating temperature and the dew point temperature, thus preventing condensation from forming in the dry grinding system. The temperature control after the mill, TIC, is activated and set to a value of around 75 degrees Celsius. During operation, a temperature of 95 degrees Celsius will be adjusted downstream the mill. Whilst the entire plant is warming up, the carbon monoxide oxygen analyzers are switched on. The controlled systems at this time are pressure measurement upstream of the mill, PIC, measurement of process volume flow, FIC, and temperature measurement downstream of the mill, TIC, during operation. Inert gas is still being fed into the plant. The hot gas generator consists of a main burner for blast furnace gas, synthesizing gas, etc., with a coaxially integrated start burner for coke furnace or natural gas. The start burner fulfills various functions. It serves to warm up the combustion chamber muffles to temperatures of over 350 degrees Celsius and the entire plant to temperatures higher than 65 degrees Celsius. When these two preconditions are met, the main burner is enabled. At the same time, the volume flow of processed gas is set to 70% of the maximum value. The vacuum pressure after the mill continues to be regulated to a value of -3 millibar. In order for the coal feed and, as a result, grinding operation to be enabled, the temperature after the filter must be above 65 degrees Celsius, and the oxygen content must be lower than 12% with moist gas. Working pressure control is active, and the grinding rollers can be lowered. The material feed is set to the minimum throughput rate of 40%. All controllers and the associated controlled systems are set to automatic. TIC after mill, PIC before mill, FIC after filter, PDI mill differential pressure, QIC oxygen control after filter. The grinding plant is now performing self-inert grinding operation. Inert gases are no longer fed into the plant. For safety reasons, inert gas is only applied to the fine coal silo for the whole time that the grinding plant is running. The coal grinding plant is shut down gradually according to a prescribed shutdown sequence. All carbon monoxide analysis equipment must remain active during a standstill. Here you can see a two-line coal grinding plant that produces coal dust for use in the steel and iron industry, which has the same structure as a self-inert central coal grinding plant. If the plant is to be used in the branches of industry mentioned in the introduction, certain plant components are adjusted to meet the specific requirements of those sectors. The current state of the art dictates that a considerable proportion of the reducing agents needed in blast furnaces is injected into the blast furnace through blow molds in the form of coal dust. This technology is known as PCI, pulverized coal injection. The plants used to produce the coal dust were designed as self-inert coal grinding plants. In 1986-87, Loesche had a major role to play in developing these systems. The first such plant came online in Germany at Loesche in Dillingen. Now we will show you how the plant is structured. First, we will follow the flow of material from raw coal to coal dust. Then we will see the path that the process gas takes. The raw coal is transported on a conveyor belt to the raw coal bunkers, which are mounted on load cells. The material is usually discharged from the raw coal bunkers via drag chain feeders, which are steplessly controlled and equipped with a regulator for height. The raw coal is fed in centrally via the classifier or from the side of the mill. The raw coal is dried and ground in the mill. This one is a Loesche mill type LM28.3D. The required product grain size is achieved by means of a dynamic Loesche classifier. The coal dust process gas mixture is fed to the bag filter via process ducts. The bag filter is where the coal dust is separated from the process gas. The coal dust leaves the filter system via discharge units. The connected rotary valves form the air seal to the plant components that are conducting process gas. Chutes transport the product to the fine coal silos. These fine coal silos then link up with the conveying systems of the PCI system in order to transport the product still further. Heat must be fed into the system in order for the dry grinding process to be carried out. This is where a hot gas generator system, developed and patented by Loesche and consisting of a steel combustion chamber, known all over the world as a Loma heater, and a multiple lance burner comes in. Blast or coke furnace gas is used for coal grinding plants in the ironworks industry, with synthesizing gas or other available gases used for coal gasification plants. Cleaned gases leaving the bag filter are heated up to the temperature required for dry grinding in the hot gas generator. The hot gases are then transported to the mill via ductwork. The coal dust process gas mixture leaves the mill via the classifier and reaches the bag filter, where the fine coal is separated out. The cleaned process gas leaves the filter. The cleaned process gas is forwarded to the process gas fan via ducting. The fan generates the pressure difference required by the grinding process. Once it leaves the process gas fan, the whole volume flow of gas reaches the flap system, where it is divided into a component that exits the system via a stack and another component that is fed back to the mill's hot gas generator via the return gas duct. A venturi tube in the return gas duct measures the volume flow. As aforementioned, there are 4 major industrial sectors where Loesche coal mills are being used. In the iron and steel industry, the produced pulverized coal is being injected into blast furnaces. This is known as PCI, pulverized coal injection. Worldwide, more than 55 of these self-inert coal dry grinding plants have been supplied by Loesche and are located on all continents. The need for pulverized coal for coal gasification plants has significantly increased over the last years. During the gasification process with coal, petcoke, biomass, etc., synthesis gas is being produced, which is either used for energetic purposes in combined cycle power plants or for the production of chemical base materials. In 1990, Loesche supplied 3 coal dry grinding plants for one of the first industrial-sized power plants with integrated coal gasification in the Netherlands. In the cement industry, the pulverized coal, or petcoke, produced in a Loesche mill is used for the operation of the rotary kiln burners. With regard to the carbon dioxide balance, biomasses are being introduced in power plants in an increasing amount. Here, you can see a power plant in Denmark operating with pulverized fuel made out of wood pellets. The utilization of lignites in process engineering plants increased a lot over the last few years. Several of these plants are located in the German lignite areas, like Lausitz, near Leipzig, and the Cologne region, and are in operation. Due to consistent development, Loesche is today able to supply large-scale mills with a 6-roller technology, also for coal grinding with a capacity of up to 200 metric tons per hour and more. The high availability of this scale-up is based on long-time experience of this technology in the field of Loesche's cement raw material mills. Herewith, it's possible to operate big gasification unit structures or other large-scale plants with only one mill. Loesche is always one step ahead.